Today we are going to discuss about the topic of KVL. We are not going to discuss any problems right now. We just want to have a very strong concept of applying the KVL to any of the circuit that is given to us. Now there are different books, there are different conventions, but I will say that if you are following a single convention, stick to it. Don't go here and there. If you are having a pre-notion that this is that, means a particular sign or something like that, then please stick to it. Otherwise, you will face a lot of problem here. Okay, but my concept and my techniques are very easy. You can easily understand it and why I am doing it, and you will be able to remember this in your further problem solving analysis. Okay, now just start with a very simple circuit. Let us just consider a single source is present and two loops are there. Then that will be easier for us to understand how to apply the KVL. Okay, now we are going to that. Say this is a voltage source. I am going to just discuss about the DC part today. We will be again uploading a video of KVL which will include the AC part analysis also. Okay, now say a particular circuit is looking like this. Okay, so this is my circuit R1, R2, R3, R4, R5, and this is my V. Whenever you are having your circuit at your hand, then you have to put the current's direction. In case of KVL, always remember KVL and KCL, there are two laws and they are dependent upon their own rules and conventions. While discussing KVL, we are assuming some concepts, some particular conventions for this analysis only. Okay, now say we can take the current as we like, clockwise or anti-clockwise, but I will always take the current to be clockwise, means otherwise the confusion will be there which direction to take actually. For different circuits we can actually change our convention, but I rather prefer only clockwise direction. Okay, so this is my I1, say this is my I2. Now we are going to write the voltage equation for a particular loop. So the first loop is containing this current I1, that is loop 1. What is loop? We will be discussing it at our later classes because the graph theory will be there and we will be discussing about nodes and loops there. Okay, and the other KVL classes will be there also. There we will be able to solve different specific problems which will include some specific tricks. Today we are just going to analyze the circuitry trick and how to apply the KVL. In case of loop 1, if we are going in the direction of the current, always go in the direction of the current. Okay, that is this V1, V is at your hand. Na? So we are going in the direction of current inside the V, not from V. Okay, from V the positive terminal, from the positive terminal the current is going outward. But if in the current direction we are moving, in this V we are going from negative to positive, means what? The voltage is rising. In case of KVL, voltage rise, it signifies positive sign, and voltage drop, it signifies negative sign. Another thing, another very important point, always if there is a resistance, there will be a voltage drop. If there is a resistance, there will be a voltage drop. Okay, then negative sign is very much predetermined for the resistance itself. We will be looking at the circuit. Okay, now this is from negative to positive, means what? Voltage is stepped up or it is raised to a level, it is there, it is increased, that is why this will be plus V. Now the current will be going through this resistance R1, that is the I1 current. So this will be minus. Why minus? Because resistance will have voltage drop itself. Then minus I1 into R1. Okay, now in case of this R2, what we can see, the current I1 is going downward and from this part the current I2 is going upward. Then as we are applying the law in the loop 1, we have to give the advantage to the I1 part. means the dominating current is that I1. So we have to write R2 into I1 minus I2, the resultant current which is actually going through this resistance, and the drop is there, that is why negative sign. Then for this R5, what we have to write? I1 into R5, that is equals to 0. Now you just have to solve these things. The values will be given to you. The V value will be given. R1, R2, R3, R4, different values will be given. You have to calculate this and you will be getting an equation in terms of I1 and I2 from here. Then again we have to do the same thing in loop 2. What we have to do? We just have to follow the same principle. With this R3, the I2 current is moving, then minus R3 into I2. This R4 minus R4 into I2, and for this R2 again we are having the same resultant current, but as we are in the loop 2, the dominancy has to be given to the current I2. Then what we have to write? We have to write R2 into I2 minus I1 equals to 0. Again from here we will be getting an equation of I2 and I1. So there will be two variables, two equations. By simultaneous equation solve, we will be able to easily calculate what is the value of I1 and I2. And from this, in case of any resistance, you will be able to calculate what is the voltage drop across it. If someone is asking you what is the voltage across this resistance R2, then you have to take I1 minus I2 into R2 if I1 is greater. If I1 is smaller, then the equation will be I2 minus I1 into R2. Means the voltage drop you have to take in a positive sign. Then the polarity will accordingly change, but this current has to be taken like this. The bigger current will be at the front. Okay, so this is it. The application of KVL, the rules, the convention, this is it. If you be able to solve the problems like this, then this is the general method. You can apply in any sum, and that will be very much feasible and time saving for you. Just do it, just practice it, you will be able to solve any problem with it. Thank you for watching this video. If you like the video, then please subscribe to my channel. I will be uploading this kind of videos again. Thank you.